All right, for today's lesson, I just wanted to do a quick run through of how you can use the graphing calculator to help you answer STAAR type questions. And so all of the questions I'm about to go over, if you just know function transformations, you could probably do faster than this. But on a high stakes exam like the STAAR exam or the ACT, it might be worth your time to just double and triple check using the calculator. Or, this has been a tough year, this can be a way out for you. So what I've got here is side by side Desmos on the left and your Delta Math assignment on the right. And I'm going to show you how you can get through this assignment using the graphing calculator. So here's question 1. The graph of y equals f of x is the solid black graph below. Which function represents the dotted graph? So one thing I could do here, right, is when I see this function, I recognize it as the absolute value function. So I'm going to go ahead and I'm going to type in, I'm just going to say the absolute value of x, because that's what this looks like. And if I am just struggling to remember what the transformations are that make this function flip upside down and move 3 to the left, well, I can just play around with it. So let's go ahead and let's try answer choice A here, and let's see what happens. If I throw a negative sign out front, that's a good first sign. And if I add a plus 3 in there, let's see what happens if I add a plus 3. There we go. That actually looks like the correct answer there, right? So there we go. That's how you could very quickly answer this question if you, didn't quite remember how these transformations worked. Let's see part 2. Transform functions. Okay, so now this one, right? This one is having me transform a cube root function. And so the idea here is I can go and I can type into, let's go back here, functions. Remember, this is NTHROOT if you are typing this in yourself. We want the cube root, and so the first thing I'm going to do is I'm just going to enter the parent function, right? And you can see this is the same one because it has points here at 1, 1, right? But what we want to do is we want to change this function by doing -3 on the inside of the radical, and so clearly that moves us right 3. So I'm going to move my function right 3 using that green center dot, and then we're going to do -4. Okay, so we must have moved down right 3 and down 4. This would be, didn't mean to start over, right 3 and then down 4 here. Let's go ahead and submit the answer there. And so again, if you just know your transformations cold, don't feel like you have to do this, but it's something that's there to help you if you need it. All right, so that's 2 sections down. Let's see here, parabola features. Okay, this one is less of a graphing help one. It's just there are a few key features of parabolas we want you to know. Looking at this graph here, right, it's important that you are able to identify the y-intercept, and so that's where we cross the y-axis. In this case, well, it's going to be 1 point, and it's going to be at x is 0, y is 7. And so that would be the y-intercept of this function. The other things that it could ask is the roots of the parabola. The roots mean what values of x make y equal to 0. And so in this case, that happens at x is -7, y is 0, and at x is -3. Y is 0. So that one's less of a graphing calculator assistance one and more just the vocabulary. All right, let's see, finding roots from a graph. Same thing here, just sort of different vocabulary. So this one's really sort of like a gimme here. The solutions to f of x equals 0, you just have to remember that f of x is a fancy word for y. And so we're going to have 3 of these here. It looks like there's, so notice I hit that plus button at -1, 0, and 2. Those are going to be the 3 zeros because those are the 1, 2, 3 places where f of x, y equals 0. Those are also called the roots. And so today is all about just like graphing terminology. Okay, so now this is one where you can really bust it open using the graphing calculator. Which equation choice represents the graph shown below? So what this problem is getting at, right, is can you look at these roots and say, okay, if x is, for example, -4, see how we cross the x-axis at -4? That means when x is -4, y is 0. What that tells me is it's either answer choice C or D, these two bottom ones. How do I know that? Because they have x plus 4 parentheses, x plus 4 factors. So if I plugged in -4, those x plus 4 parentheses would be 0. What I also see is that the same thing happens at +7. And so still that helps us choose between D and C because they both have x minus 7. But it's this one here that also has the x out front, which gives me that 0 at the origin, at x equals 0. But say you're struggling on this, right? The reason we're practicing this again from like a STAAR hack perspective is, you get 4 minutes per question here. You would totally have time to plug this thing in and look at it, right? And you can play around with the settings here. This is probably something you want to get used to, is saying, okay, I want to make it really look like what it looks like on this graph. And so I'm going to make it have a 10 by 10 grid here. I'm going to have both the x and the y axis go by 10. Maybe the y actually, it looks a little bit nicer if we go by 20. So we'd have from 20, -20 to 20. That's probably going to look a little bit cleaner. Yeah, you got to zoom out to see it, but if you kind of play around with it here and it looks better on like a bigger, what it would look like on your computer when you're actually doing this on the STAAR exam is more like this, right? So you can actually use this to find these points -4, 0, and 7. And so play around with that again. You can keep changing these y values until they really show you. Let's maybe even go like -250. Now we're talking here to +250. So now we can really see that this is the same graph here. So that's another one there. And again, these are all totally faster without the calculator, but the calculator is there for you. All right, and we have one left here. Same idea here, just a little bit tougher. And so this is one where it's probably more likely that you'll need to use the calculator here. So when I look at this, there's actually only one zero of this function. And so the only zero is at -6. So there has to be a 0 at -6. That means once again, I'm choosing between C and D because they both have those x plus 6 parentheses. So what's the deal here with x squared plus 9? It turns out, right, that the answer is in fact C, because if you think about x squared plus 9, there's nothing that can make that 0 in real numbers, right? Because if x was 3, 3 squared is 9, you'd have 18. If x was -3, -3 squared is 9, you'd have 18. And so the only one that's going to work here is going to be this answer choice right here. And so let's just see what this would look like. X plus 6 times x squared plus 9. And so there we go, right? It's going to be a little bit stretched compared to our graph, and you can play around with this thing. Let's maybe make it only go up to 150, make it look a little bit more like our graph here. But at the end of the day, what you are looking for is the correct 0 here, which we do in fact have. We have the one correct 0 at -6, 0. So that's just how you could use the graphing calculator to help you answer these STAAR questions today.